Hello students. So in this video, we are going to discuss about time-independent Schrödinger wave equation. Actually, there are two kind of the Schrödinger wave equation, time-dependent and time-independent. So time-dependent Schrödinger wave equation that we discussed in the previous video. So in this video, we are going to concentrate fully to derive about the time-independent Schrödinger wave equation. So for deriving of this equation, first we need to think about the de Broglie hypothesis that we have seen in a regular class. So now, first you think about the equation for the de Broglie wavelength. So what is the wavelength of the de Broglie? Means that is lambda is equivalent to h by p, or we can simply h by mv that we can take. So here lambda is a wavelength, h Planck's constant, mass m, velocity v. As according to the de Broglie theory, a particle of mass m moving with a velocity v for corresponding that particle, what will be the wavelength? That wavelength is this one, lambda is equal to h by mv. That is okay. If the particle has a wave properties, that particle is expected that there should be some sort of a wave equation. Okay, so that wave equation should describe the behaviors of the particle. That is okay. So now we need to think about the classical differential equation of the wave system. What is a classical differential equation of the wave system? So we in three-dimensional, for the case of the three-dimensional direction, we can think of the classical differential equation. What differential equation we are utilizing in a classical way? This one, dou square psi by dou x square plus dou square psi by dou y square plus dou squared by dou square psi by dou z square. That should be equivalent to the 1 by v square dou square psi by dou t square. Consider that this is equation number 1. This is the classical differential equation of the any kind of the wave system. Here, what is a psi? The psi is nothing. It is a wave displacement for a de Broglie wave at a time t, and x, y, z coordinates. These are all the coordinates of the particle, and v is the velocity, wave velocity. So the same equation can be rewritten by using the Laplacian operator. Del square psi is equivalent to 1 by v square dou square psi by dou t square. Here, what is del? That is a del square. That is a del square operator is a Laplacian operator. That is nothing. Dou squared by dou x square plus dou squared by dou y square plus dou squared by dou z square. This is considered as, it is called as Laplacian operator. Okay, that is called a Laplacian operator. So now from this equation, we need to derive the time-independent Schrödinger wave equation. Now for this, consider this is wave equation. This del square psi equivalent to 1 by v square dou square psi by dou t square is a wave equation. Now we need to think about the solution for this wave equation. What is the solution for this wave equation? That solution gives us a periodic displacement in terms of the time t. So the solution can be represented for this case is psi of x comma y comma z comma t, that is equivalent to the psi naught of x comma y comma z exponential of minus I omega t. This is what, this is equation number 3. Here psi naught means psi naught is a amplitude at the point considered. Psi naught is the amplitude at the point where you consider that point. Okay. So it is a function of position. See here, the psi naught is a function of position only. That is why we mention x, y, z only, not a time. But here psi is an amplitude. Here this actually this wave function, solution wave function psi includes all position and time. But psi not depend on the time. It independent of the time. It includes only the position coordinates x, y, z. That's all. So now here we need to start the derivation. You consider this solution. For this, in this solution, here you need to make the differentiation. Okay, differentiate this equation number 3 twice with respect to the time what? T. With respect to time t. And what we need to get for when you differentiate it, first you differentiate one time. Actually, we need to make the two time double times the differentiation of this equation number 3. So first you differentiate. So what we will get when you differentiate this equation, first you will get dou psi by dou t is equivalent to psi naught is a constant, so you keep psi naught. And when you differentiate this exponential factor, what you will get? Minus I omega psi naught e power minus I omega t. This is one-time differentiation. Like that, you need to do the second order differentiation. So dou square psi by dou t square equivalent to, when you differentiate again, these are all constant, keep as such psi naught. Then again, if you differentiate, minus I omega e power I minus I omega t. So solve this in a simplified way. So dou square psi by dou t square equivalent to, when you simplify this, what you will get? Minus, that will be plus, right? Then I square omega square psi naught e power minus I omega into t. When you simplify further is, what you will get? Minus omega square, and this psi naught e power minus I omega t. See here, this psi naught e power minus I omega t becomes what? It's a psi as per the equation number 3, and this part can be written as psi only, right? So you consider, so now the simplified equation, that is nothing, dou square psi by dou t square is equivalent to minus omega square psi. This is equation number 4 you consider. So now you need to substitute this equation where, see this equation, equation number 2. So in this equation, what is the del square psi? That there you need to substitute. Okay. So what is the equation number 3? You take the same equation, full equation. Oh, sorry. Okay, so take that equation number 2. In that equation, you substitute. If you substitute it, you take the equation first here. Equation 4, you need to substitute there. If you substitute there, means what you will get? Del square psi equivalent to the, instead of the first part, see, 1 by v square, and instead of this dou square psi by dou t square, you need to substitute minus omega square psi here, this one. So finally, what you will get? Minus omega square by v square psi. That's all. So this is equation number 5. And here you need to make some further simplification on this equation. First, here you see you have the omega square by b square. And what is omega and what is omega b? And we need to make the further simplification for this. So for getting that, you please take the omega value. Omega is nothing, 2 pi nu. Means nu means it is a velocity by wavelength. We can write like that. So velocity v by wavelength. Nu can be rewritten as v by lambda. So from this v omega by v, that is nothing. We can write 2 pi by lambda. So from this omega square by v square, that is, that can be rewritten as 4 pi square by lambda square. So take this one and substitute in the equation number 5. So phi becomes del square psi equivalent to minus, instead of omega square by b square, you need to substitute this one. 4 pi square by lambda square psi. Right. And again, make further simplification. Del square psi plus 4 pi square by lambda square psi equivalent to 0. Right? So you consider this is equation number 6, and finally you may consider that this is equation number 7. And now we have the equation like this. Again, you need to make the further simplification. Here we are doing just mathematical in a simple way. There's no big task here. And here we have a lambda. What lambda? Actually, as per the wave nature, we need to think about the de Broglie wavelength substitution here. You know what is wavelength equation? Lambda is equivalent to h by md. Substitute again. The same equation becomes del square psi plus 4 pi square. Instead of this 1 by lambda square, you need to make m square v square by h square psi equal to 0. Right. Consider again, this is equation number 8. So here almost we reached the equation, final equation, but here still we have m square v square. No, that m square instead of that m square v square, what we can rewrite in terms of the energy E and voltage, that we can make something. Right, you keep the equation number 8. So that instead of that m square v square, so what is the exact value in terms of the energy and potential that we need to get. So now for getting that m square v squared equation, first you need to think about the total energy. What is the total energy that we know? Total energy E is, that is nothing but the kinetic energy and the potential energy. Am I right? So total energy E is equivalent to both the kinetic energy and potential energy. So from this, you just make this very simple mathematical steps from this and get the m square v square. So 2 times of E minus V equivalent to m v square. Again, if you put m on both sides, it becomes this one. So from this, m square v square equivalent to 2m E minus V. That's all. So now I have got the m square v square equation. Now you take this m square v square and substitute in the equation number 8. And that same 8th equation becomes again, how it will be told? Del square psi plus, take this 2 and 4, 8 pi square. Right, instead of this m square v square, you need to substitute all this. M by h square E minus V psi equivalent to 0. This is what? This is Schrödinger time independent wave equation. This is Schrödinger time independent wave equation. But okay, but if you want to further, you can simplify the same equation in a different aspect. See, this is somewhat lengthy one. No, you can apply the h cross also. You know, h cross means what? H by 2 pi. Right? You apply the same here in this equation, and how it will be changed. The same equation can be turned as del square psi plus, and here, if you put the h cross here in the down, we need to suppress this one. So after get suppressing it, what you will get? 2 m by h cross square E minus V psi equivalent to 0. That's all. This is simplified one, further simplified one. This is also the Schrödinger time independent equation. See, in this equation, there is no time component. So del square psi plus 2m by h cross square E minus V psi equal to 0. So here one small case for a free particle. For a free particle means the potential energy V can be 0. If V is 0 means what you will get, the same equation turns into del square psi plus 2m E by h cross square psi equal to 0. That's all. So this is the case only for a free particle when potential energy V is equal to 0. And this equation, no, this is a final equation. This is okay. This is Schrödinger time dependent wave equation. Both are same. This and this both are same. And this is some special case when V equal to 0, you can use the last one also. Okay. Okay, student. So this is the time dependent wave equation. So please go through this same uh, derivation, how to derive it. Please take care. Thank you. Thank you so much, students. Thank you.